Section 3.4 really doesn't have any new vocabulary. What the expectation is here is that we're going to multiply fractions and add the concept of a mixed fraction to our multiplication problem. So as we're looking here, problem number 1, it's a good example to start with. We have 2/5 multiplying by 1 2/5. In order to do that, we have to put it in fraction form. So the 2/5 part's fine, but we need to deal with the mixed number. So 1 times 5 is 5, plus the 2 gives us 7/5. And we're going to multiply, remember, straight across. We need to first check, or should first check, is there anything we can reduce? There's not in this problem, so we're multiplying straight across. So 2 times 7 is 14, 5 times 5 is 25. Double check to make sure there's no reductions or simplifications. There's not, and we're all done. Problem number 4 has 2 mixed fractions to deal with. So we just take them one at a time. We have 2 as the whole number here. They're in groups of 5, so 2 times 5 is 10, plus the 3 gives us 13/5. 1 times 4 is 4, plus 1 gives us 5/4. And then we have the possibility of doing some reductions before we multiply. We can multiply just straight across, would give us 65 over 20, but then we have to reduce that. And so again, I like to reduce before we multiply. I notice that 5s are common, so there's 1, 5, and 5, and 1, 5, and 5 here. So then I'm multiplying straight across. 13 times 1 is 13. 1 times 4 is 4. Now I have an improper fraction. Remember, we have to fix those. So how many 4s in 13? That's going to be 3. That'll use up 12 of those 13 because I have 3 groups of 4. So I have, once I subtract, I have 1 left over. I'm still in base 4. So that converts then to 3 1/4. Problem number 7, again, they're adding more fun little concepts to us. Now they throw in the addition of a whole number when we're multiplying. So we take things one at a time again. So 3 times 5 is 15, plus 3 would be 18/5. 1 times 4 is 4, plus 1 is 5/4. And whole numbers, remember, always go over 1. So that becomes then 5 over 1. And we're multiplying again straight across. So as always, we're going to see, is there any number on the top that can be reduced with any number on the bottom? Well, again, I notice I have 5s. So how many 5s in 5? 1. 5s in 5 there, 1. I could have used either 5 on the top. It really didn't matter. I notice that both 4 and 18 are even. Therefore, 2 goes into both. So how many 2s in 4? 2. 2s in 18, 9. So again, we're going to multiply straight across. So 1 times 9 is 9, and times 5 would give us 45 over 2. 1 times 2 times 1. Well, now we definitely have an improper fraction because we have 45 over 2. So how many 2s in 45? Well, that's going to be 22, because that's going 2 times 22 is use up 44 of that 45. We have 1 left over, and we're still, our base is 2. So we have 22.5. Well, with anything, they're going to not only throw just multiplication, they're also going to throw division at you. So we have problem 29 here. We have 5 2/3, and we're going to divide by 1 1/9. We have an extra step, remember, when we divide. But first off, before we do that, we have to make these improper. So 3 times 5 would be 15, plus the 2 is 17 over 3. 1 times 9 is 9, plus 1 is 10 over 9. But it's still a division problem. All we did was make them improper. So remember, whenever we're going to solve a division problem involving fractions, we're going to flip that number behind the division sign and make it a multiplication problem, because we've been doing those. There's nothing new there. So we have to flip this over, do the reciprocal, and make it a multiplication problem. So now we're going back, now that we've done that. So we've had 2 steps so far. We've had to make them improper. Still a division. Then our next step then is to do the reciprocal of the fraction behind the division sign and change it into a multiplication problem. Now we're also going to check, is there any number on the top that can be reduced with any number on the bottom? Well, I notice that 3 goes into 9. So how many 3's in 3? 1. 3's in 9, 3. 10 doesn't go into 17. There's no help there. So we multiply straight across. 3 times 17 is 51. 1 times 10 is 10. So now how many, since we have an improper fraction, how many 10's in 51? There are 5. That uses up 50. We have 1 over 10 left. So 5 and 1/10. Let's do one more of those involving a whole number. So let's do problem, pick one. How about 39? So we have 8 2/3, and we're going to divide that by the whole number 6. So again, our first step then is to make this improper. 3 times 8 is 24, plus 2 gives us 26 over 3. And all we're going to be dropping this down then is to whole numbers go over 1. So that's our first step, is to just put it in fraction form. And then of course, since we're dividing, we have to do the reciprocal by flipping. So 26 over 3 times 1 over 6. Remember, because we flipped that. And now we're going to multiply straight across. So is there any number on the top that can be reduced with any number on the bottom? Well, I notice that both of these are even, so I know that 2 goes in. So there are 2 goes into the 6 3 times, and 2 goes into 26 13 times. So 1 times 13 is 13, 3 times 3 is 9. It's improper, as you notice. We have to fix that. So how many 9's in 13? We have 1, and there are 4 9ths left over. All right, the homework is just that same way. Go nice and slow. You need to make sure you make them improper fractions first, reduce, and then multiply. And then the additional step with a division problem, make them improper first, then flip. Don't flip first. That'll get you all messed up. So improper, then flip, and you should be just fine.